So in this section, we're going to be covering this thing known as rotational dynamics, which is essentially the movement of rigid objects. So maybe like a sheet of metal, for instance, and how they can link with circular motion in a sense. So in this section, we're going to be learning the definitions for a moment and a torque and how they're different, how to locate the center of mass of a lamina, the difference between a moment and a moment of inertia, because they are different. These things called the parallel and perpendicular axis theorems. How to solve moments calculations. How to solve problems involving angular momentum and Newton's second rotational law. So there is quite a bit in it, but a lot of it can be broken down fairly simply. And the first thing we're going to be doing is the moment of a force. So the quantity known as a moment is the product of the force applied multiplied by the perpendicular distance from the force to the axis. Now this is where all the axis stuff is going to come in now. Not Nazi related, but as in axis, XY axis. A moment is also referred to as a turning force. So for instance, if you pull on a door handle, you create a turning effect on the door that is in the arc of a circle, hence coming in with circular motion. But what happens if the force isn't at an angle? So for instance, if you stood sort of angled to the door and tried to pull the hinge this way, well, what you get is that the force is actually created by the perpendicular component of the force. So in general, the moment of a force is equal to the force times the distance times the sine of the angle between the force and the object. And as a little diagram, this is roughly what it would look like. So this little nudge here, this indicates the hinge, also called a pivot. So that's where the force is going to turn. So it's going to turn around this way. So we're going to be using that equation, m equals fd sine theta, for some calculations in the next few videos.